I'm Erika. Let's do some GMAT assumption questions. Before we jump in, make sure to ring the notification bell. I put out new videos every Wednesday, and there's a bunch of other great stuff in between from the other experts here at Target Test Prep. Okay, GMAT assumption questions are dreaded by many of my students. The negation strategy haunts many a test taker's dreams. And that's unfortunate because assumption is one of the most common GMAT critical reasoning question types. But like many GMAT question types, assumption really isn't all that if we approach it strategically. In this video, we're going to go through 3 levels of GMAT assumption questions. 1 easy question, 1 medium question, and 1 hard question, where the hard question stumps nearly half of Target Test Prep GMAT students. However, we're going to make all 3 questions look easy using simple strategies. We'll start with the easy question to introduce our approach to assumptions and critical reasoning in general. Okay, so the first thing that you're going to notice about this question is that there are no answer choices for it. And don't worry, they're coming later, but they're not here right now on purpose. If you've seen my video on 6 strategies that do not work, you know that the default strategy for many test takers on verbal is to read everything that's on the page, including the answer choices, and then start solving. And that is a mistake because the test maker lays the majority of their traps for verbal in the answer choices. And so when we go into the answer choices, treating them as helpful hints, right, going in blind, we end up going, oh yeah, I've seen that phrase before. Yeah, no, that makes sense. That sounds convincing. Or, oh, I hadn't thought about it that way. And we end up letting the test maker, who is not our friend, who is actively trying to trick us, get into our heads. So rather than doing that, rather than relying on the test maker, we should rely on ourselves. A better strategy instead is to go into the problem independently and try to figure out what's going on independently and try to come up with our own answer independently. And this is the act of predicting. Now, armed with our prediction, which we came up with independently without the test maker getting their hooks into us, we can then go into the answer choices, go into that minefield armed with our prediction. And that's going to help us, hopefully, to avoid those wrong answer traps and locate the correct answer more easily. So, can we actually get rid of the answer choices like we have here on test day? No. But if we practice this way enough, we are going to more easily be able to do this on test day, even when there are answer choices there to tempt us. Okay, so what do we have left without our answer choices? What is it that we are engaging with? Well, we have our passage and we have our question stem, which tells us that this is an assumption question. Makes sense. That's what this video is about. Now, it doesn't really matter that this is an assumption question right now, because for the vast majority of critical reasoning questions, our first step is the same. It's to deal with our passage. Now, for the vast majority of critical reasoning questions, the passage is an argument. It is composed of premises or facts, things that we are not arguing, things that we are just assuming to be true, and a conclusion. Now, in a correctly formed argument, a conclusion is something that must be true. It is an inference. It is something that follows logically from the premises. However, in critical reasoning questions, the conclusions are flawed. There is something wrong with this argument. The premises do not naturally lead to the conclusion. So for these critical reasoning questions, our goal is to break down this argument, find the premises, find the conclusion, and find the flaw, find where that argument breaks down. Then what we do with that flaw depends on the question type. So is it a strengthen? Is it a weaken? Is it a find the flaw? Is it a paradox? Is it a assumption like this one? Now, of course, the exception to the rule is the inference question. And in the inference question, we are given a passage that is just premises, just facts. And we are meant to draw the conclusion or the inference, the thing that must be true. And we have to draw it correctly, unlike for these other questions. But that's not what we're doing here. We're dealing with an assumption question. So we are going to go into the passage and break it down and find the flaw. Okay, so without a sufficient dietary intake of vitamin B12, humans will develop vitamin B12 deficiency. That's a fact. That's a premise. We're not arguing that. Okay, great. Vitamin B12 is found in high concentrations in red meat. Another premise. Therefore, this is a classic conclusion transition word. So this is pretty much a dead giveaway that this is our conclusion. It's also at the end of the argument, which is the classic place for conclusions to be. They are not always there, but in an easy question like this one, often the case. Okay, therefore, to prevent vitamin B12 deficiency, humans must eat red meat. This is our conclusion. And as we know, it is flawed. So what makes this conclusion flawed? Well, something should jump out at us, and that something is the word must. In conclusions, in inferences, extreme language is one of our classic clues that our conclusion is going too far. Now, why is that? Well, it is a lot easier to prove something that's a little bit more reserved, something that isn't going so far. So something like to prevent vitamin B12 deficiency, it is a good idea to eat red meat, or red meat can be a good way to prevent vitamin B12 deficiency. It's easier to prevent vitamin B12 deficiency if you eat red meat. Those are all pretty reserved, right? Those are all easier to prove because they're not going too far. They're not too extreme. Here we have humans must eat red meat. That is the only option. You have to do it. Well, does that necessarily follow from our premises? Our premises are just saying you need B12 and you can find B12 in meat. That doesn't mean you have to eat meat. So what's our flaw here? Do I have to eat red meat to get B12? Or is it possible that I can get B12 from something else? Okay, now that we have our flaw, what we do with it to predict depends on our question type. So if we had a find the flaw question, great, our flaw is our prediction, we are done. We can go into the answer choices and that's what we're going to look for. If we had a weaken question, okay, we're going to take that flaw and we're going to use it to weaken the argument. So maybe we can get vitamin B12 from white meat. We can get vitamin B12 from nuts and seeds. Maybe the average vegetarian diet has enough vitamin B12 in it to prevent vitamin B12 deficiency. Maybe the only recorded cases of vitamin B12 deficiency have been in people who were starving. So in all of those cases, humans do not need to eat red meat. So those are weaken questions. Now, with strengthen and assumption questions, we are trying to do the opposite. We are trying to fix the flaw to make the argument better. So instead of saying we can get B12 from something else, we're saying we can not get B12 from something else. The difference between strengthen and assumption questions is how far they go in fixing that flaw. With strengthen questions, we can do all sorts of weird and extreme things to fix the flaw to make the argument better. So maybe for a strengthen answer choice, we'd say we cannot get B12 from something else because even though there is B12 in every food item, it is in a form that cannot be processed by the human body. In fact, the only food that has B12 in a form that can be processed by the human body is red meat. So yes, you have to eat red meat. Do you see how that's kind of weird? It's kind of extreme. All, only, right? That's fine in a strengthen question, right? We can strengthen at any cost, by any means necessary. That's not the case for assumption. Assumptions are things that must be true for the argument to be true. Something that must be true so that the conclusion must be true. It is something upon which the support for the conclusion depends. And just like with the conclusion, things that must be true are usually pretty reserved. They don't go too far. So with an assumption question, we're not going to make up some crazy story. We're just going to say our assumption is that we cannot get B12 from something else. That simple. So notice that our prediction for our assumption is just the negated version of our flaw, or it is our flaw with a not added, or in some cases removed. Now we're going to revisit this idea of negation when we get to our answer choices. But for now, we have our prediction. We cannot get B12 from something else. Now we can look for that in our answer choices. Okay, now we have all of our answer choices. Now, again, the default is just going to be to read every single one of them word by word, right? And really engage with each one, but we're not going to do that. Instead of engaging with it, we're going to look for our prediction because there's something we can look for. It's the concept of something else. So maybe we're going to look for another food or another consumable, something that is going to give us B12. So looking at our first answer choice, humans who do not consume red meat, blah, 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 could not prevent vitamin B12 deficiency by using, oh, hey, vitamin B12 supplements. Let's engage with this answer choice because it has something else in it. Okay, humans who do not consume red meat. All right, so these are the people who are doing the opposite of what the conclusion says. They could not prevent vitamin B12 deficiency by using vitamin B12 supplements. They could not get B12 from something else. That's our prediction. This is our correct answer. We're done. Now, let's say we're not totally sure. Maybe we're a little bit lost in the language. We're not totally convinced. That was pretty quick, right? We can go back to our idea of negation. So just like our assumption is the negated version of our flaw, the negated version of our assumption is our flaw. So our assumption is something the argument depends on. If we take the opposite, it should break the argument apart. So we are going to do exactly what we did earlier, either add or take away a not. In this case, we can lose our not right here. Humans who do not consume red meat could prevent vitamin B12 deficiency by using vitamin B12. That is our flaw. We can get B12 from something else. So the negated version of our assumption breaks the argument. That means that this is, in fact, an assumption. This is our correct answer. Okay, now let's say you're still not feeling confident because that was the first answer, right? That feels a little bit weird. Okay, let's look at the other ones. Fine, let's start at the bottom and work our way up. Because consumption of red meat can cause many health problems, many people avoid consumption of red meat. This does not have something else in it. It does not match our prediction. Not our answer. Vitamin B12 deficiency can cause a variety of health problems in humans. This does not have another potential source of vitamin B12. No, something else does not match our prediction. Wrong. In humans, vitamin B12 is degraded by the acid found in the stomach. Does not have something else. Not our answer. Some plants, such as shiitake mushrooms and seaweed, oh, hold on, that's interesting, contain high concentrations of vitamin B12. This does have something else in it. But wait, it says it does contain B12? I thought we were looking for something that does not contain B12, somewhere that we could not get vitamin B12. This is the opposite of what we're looking for. Careful with these ones. They're surprisingly deceptive. Not our answer. Now, so using our prediction, we can pretty quickly rule out B through E, which gives us yet another confirmation that A is our correct answer. Now, imagine that we went into this problem without a prediction. Rather than quickly getting our right answer, we would have had to engage in earnest with each individual answer choice. We couldn't have ruled them out as quickly as we did. We would have had to negate each one to prove that each one is not an assumption by proving that the negated version of each one does not break the argument. You hear how confusing that is? That is an extremely error-prone process. It really twists up your head because it's hard to keep track of which version of the answer choice we're working with and what we're supposed to be doing with which version of the answer choice. It's also really easy to negate incorrectly. So by predicting, we both avoid the wrong answer traps that the test maker has laid, and we avoid the complication of negating. Okay, now that we're warmed up, let's attack the medium difficulty question. This one trips up more than twice as many target test prep students as the last one. All right, just like before, we see that we have an assumption question stem, which means that we are going to jump into our argument and break it down, but we're going to see something a little bit funny. The argument is being presented by the mayor. So this is a sign that we have a plan type argument. Now, in a plan type argument, we are being presented with a variation on our classic argument. So in our plan type argument, we are being presented with a problem, that's a premise, and then we are presented with a plan intended to solve the problem. That is also a premise. The conclusion is that the plan will achieve its goal. And just like in other critical reasoning arguments, that idea that the plan will achieve its goal is flawed. So we are still looking for the flaw. We are still breaking down the argument. It is just a slight variation on this. This makes this problem a little bit harder than the last one. Okay. Jumping in, many of our citizens are concerned by the number of locusts present in our town because the locusts feed on and often destroy crops. That's our problem. That is a premise. Effective immediately, all farmers in our town are required to plant only genetically engineered crops that produce Bt biotoxin, which kills locusts. Okay, that is our plan. Also a premise. Therefore, oh nice, we've got that classic conclusion transition word again. Therefore, over the coming growing season, we will begin to see the number of locusts in our town decrease. That is our conclusion. That is the idea that the plan is going to succeed in achieving its goal. Okay, so what's the flaw? Now, if something's jumping out at you immediately, that's great. I'm going to be honest, nothing jumped out at me when I read this problem. I looked at the plan, effective immediately. You're required to plant only genetically engineered crops that produce Bt biotoxin, which kills locusts. I don't know, that's a pretty solid plan, right? And the conclusion seems like it would follow. It's not saying all of the locusts will be gone, it just says it will decrease. I don't know. This seems pretty solid, but I know that it's not. I know that there is a flaw. So I'm not going to let the fact that I am not able to see it stop me. I'm going to come up with a general flaw that's as specific as I can get it to the conclusion, and I'm going to let that inform my prediction. And it's still going to help me. Okay, so the conclusion tells me that we will begin to see the number of locusts in our town decrease over the coming growing season. So the flaw must be that something, I don't know what, but something is going to prevent that from happening. So something will prevent the number of locusts from decreasing over the coming growing season. Now, just like before, we can come up with a predicted assumption by negating this flaw. So something will not prevent the number of locusts from decreasing over the coming growing season. And that makes sense. Yes, that has to be true. There cannot be something that prevents the conclusion from coming true for the conclusion to be true. Now, you might be thinking this is totally pointless because, duh, this is extremely obvious, but I promise this is going to help us when we get to our answer choices, which we're going to do right now. Now, you might think that because we don't have anything super specific that we're looking for, like we did with the last question, we should just do process of elimination and go one answer at a time, word by word. But let's give the answer choices a scan, just in case. Let's see if there's anything that jumps out at us here, something from our prediction. And we might see something kind of interesting in answer choice D, the coming growing season. That's in our prediction. And it's in our prediction because it's in our conclusion. Now, we didn't clock it as being particularly important when we read it, or even when we wrote it down in our conclusion, but maybe it was. Let's look at this answer choice a little more closely. Okay, not all crops to be planted during the coming growing season have already been planted. If that's hard to parse, let's go ahead and negate and see if that gives us a flaw. All crops to be planted during the coming growing season have already been planted. What does that mean? Well, we know from our plan that effective immediately, all farmers are required to plant crops that produce Bt biotoxin, which kills locusts. So all of the plants planted from this point on should kill locusts. But what about the plants that were planted before? Well, they don't necessarily produce Bt biotoxin, so they aren't necessarily going to kill locusts. They shouldn't do anything different than what's already been happening. So if all of the crops for the coming growing season have already been planted, they shouldn't have any impact on the locusts because they're not subject to this plan. Oh. So that breaks the argument. And if the negated version breaks the argument, the negated version is a flaw. The negated version is something that will prevent the number of locusts from decreasing over the coming growing season. The regular version of the answer choice is an assumption that we need. It is necessary for the conclusion. The conclusion depends on it. So E is our correct answer, and we were able to get there even with a crappy prediction. But let's say we didn't do that scan, or let's say maybe we didn't notice that the coming growing season was in our prediction and in our conclusion. Well, we can still get through our wrong answer choices by process of elimination using our prediction as a guide. All right, starting with A, the town could not find a more effective method for controlling locust populations. If you're a little confused by that, let's go ahead and negate to see if that's our flaw. The town could find a more effective method for controlling locust populations. Is that going to prevent the number of locusts from decreasing over the coming growing season, that there is potentially a better way to decrease the number of locusts? No, it just means that there's potentially a better way, but it doesn't make our plan a failure. This is a classic trap with plan questions, is presenting a better plan. But the question here isn't that is our plan the best possible plan? It's will our plan achieve its goal at all? And here the goal is for the number of locusts to decrease. Having a more effective plan does not prevent it from doing that. This is a wrong answer and a classic trap. Okay, B, Bt biotoxin also kills insects other than locusts, such as ants and bees. Does that prevent the number of locusts from decreasing? No, it just means that it also kills ants and bees. Is that good? Maybe not, but it's not relevant to this question. Wrong. Locusts gather in large swarms when they feed, quickly destroying acres of crops. Does this prevent the number of locusts from decreasing? No. Is it support for why we should maybe do our plan? Sure, but again, it's irrelevant to the question at hand. All right, D, large numbers of birds that eat locusts will not come to the town and wipe out the town's locust population. Again, this not makes this one kind of hard to parse, so let's just go ahead and negate and see if this is our flaw. Okay, large numbers of birds that eat locusts will come to the town and wipe out the town's locust population. Will that keep the number of locusts from decreasing? Well, no, it's actually going to make it decrease more. This is the opposite of a flaw. So if the negated version is the opposite of a flaw, that means that the non-negated version is the opposite of an assumption. This one's kind of tricky because it seems like it's going to be relevant, but it is once again an opposite answer choice. Incorrect. So while process of elimination against your prediction is slower and more error prone than simply scanning and locating your prediction, it does go a lot faster and is a lot less error prone than it would have been if we didn't have a prediction, even a crappy one in the first place. So do not let not finding the exact right prediction right off the bat stop you. Find a flaw, no matter how vague, make a prediction, and use that as your guide. All right, time for the hard question. Like I mentioned before, nearly half of Target Test Prep GMAT students get this one wrong. Okay, we know the drill. This is an assumption question, so we're going to go ahead and attack the argument, break it down, and find the flaw. I'm going to go ahead and read the whole thing. This is pretty short. You'll see why in just a second. It must be the case that eating moderate amounts of carbohydrates is beneficial for health. A recently completed study indicates that people who eat low carbohydrate diets tend to have shorter lifespans than people who consistently eat moderate amounts of carbohydrates. Okay, in our previous two arguments, the last sentence was the conclusion. That is the classic argument structure, premise or premises, and then conclusion. But if we look at our last sentence, it's just the results of a study. That's not a conclusion. That's just fact. This is about as premisey a premise as you can possibly get, which means that it is our first sentence that must be the conclusion. And actually, if we look a little more closely at it, there was a hint this whole time. It must be the case. Now, this is maybe not as obvious of conclusion language as therefore is, but it is conclusion language, right? A conclusion, when correctly drawn, must be true. So must be the case is conclusion language. So this is the conclusion. It must be the case that eating moderate amounts of carbohydrates is beneficial for health. And this is the part that is flawed. Now, if we weren't paying attention, we would maybe think that the second sentence was our conclusion because that's the classic structure, and we would be trying to find the flaw in how the first sentence does not lead to the second sentence. And that would be a huge waste of time and would probably not lead us in the right direction. So pay attention when we're evaluating our argument. Don't just go on autopilot. Okay, now that we've correctly identified our conclusion, let's identify our flaw. So do we see anything in our conclusion that jumps out? Is there a specific word or a phrase that seems odd? Well, in our previous two questions, whether we noticed them or not, there was a specific word or phrase that made the conclusion go too far, right? Either it was too extreme or it was beyond the scope of the premises. And there isn't really anything like that here. There isn't something that should jump out at us about the conclusion. But there is something that should jump out at us about the premise. And that is that we have a study that is relating two things. Here, eating low carbohydrate diets is related to having a shorter lifespan. These two things are correlated. And when we see two things that are correlated in an argument, that should immediately ring alarm bells that we have correlation versus causation as our logical flaw. Correlation versus causation is one of the most common logical flaws or logical fallacies that we see, one, in real life, but on critical reasoning questions. Now, if you're not familiar, correlation versus causation is the logical flaw in which we know that two things are linked and we incorrectly assume a causal relationship between the two. So if we know that A and B are linked to each other, we then assume that A causes B. But in reality, we don't know that. It could be instead that B causes A, or that C causes both A and B. Could be a totally different relationship. It could be that the relationship between A and B is totally coincidental. Okay, so let's apply that to our argument. Our premise, our study, correlates a low carbohydrate diet with a shorter lifespan, and correspondingly, it correlates a moderate carbohydrate diet to a longer lifespan. Now, our conclusion says that a moderate carbohydrate diet, in fact, causes health benefits. But we don't know that. We only know that they are linked. So this is a clear sign that we have our correlation versus causation logical fallacy. So our flaw, we do not know that it is the difference in carbohydrates that is causing this difference in lifespan. In fact, I think what's going on here is that perhaps there is something else that is leading to this difference in lifespan. In low versus moderate carbohydrate people. All right, now that we have our flaw, we can once again negate that flaw to predict our assumption. So we'll negate by adding a not, or in this case, a does not, for something else does not lead to a difference in lifespan in low versus moderate carb consuming people. Okay, jumping into our answer choices now that we have a prediction. Now, funny enough, just like in our first question, we are going to be scanning our answer choices for the concept of something else. So another thing that could be leading to the difference in lifespan, or in this case, not leading to the difference in lifespan in people who eat less or more carbs. Scanning our answer choices, we're going to see that A is just about carbohydrates, B is just about carbohydrates, and C is also just about carbohydrates. It's not until we get to D that we see the introduction of something else. Most people on low carbohydrate diets do not compensate for their low carbohydrate consumption by consuming greater than average amounts of animal products known to be detrimental to health. So not only does this introduce something else, but it introduces something else that we know is detrimental to health, something else that could conceivably contribute to a difference in lifespan. Okay, this one is looking really promising. Let's negate. Okay, locating or not, most people on low carbohydrate diets do compensate for their low carbohydrate consumption by consuming greater than average amounts of animal products known to be detrimental to health. So low carb people eat a lot of animal products that hurt their health. So how does this compare to our flaw? There is something else, greater than average amount of animal products, that could be leading to a difference in lifespan in low versus moderate carbohydrate people. This is our correct answer. All right, we could be done at this point, but let's go ahead and take a look at our last answer choice for good measure, because it's kind of a weird one. People who follow low carbohydrate diets would not be able to extend their lifespans by exercising regularly and refraining from engaging in unhealthy activities. Well, that sure sounds like a something else to me. So maybe this is a good candidate. Let's go ahead and negate to turn this from an assumption into a flaw. All right, people who follow low carbohydrate diets would be able to extend their lifespans by exercising regularly and refraining from engaging in unhealthy activities. So was that what we thought the flaw was? That something else could address the difference in lifespan? Well, no. What we thought the flaw was that something else causes that difference in lifespan. Nothing about addressing it, nothing about fixing it. So this is kind of similar to the alternate plan answer choice that we saw in the previous question. Now, if this answer choice were centered around the flaw that people who follow low carbohydrate diets do not exercise regularly and engage frequently in unhealthy activities, this would be great because it presents a something else that could cause that difference in lifespan. But that's not what this is doing. This is presenting something that could happen, that could fix that difference in lifespan. This is not what we're trying to do. So kind of a confusing one, but does not match our prediction. So just like how in our easy question, the key to solving was recognizing extreme language, in this, our hard question, the key to solving was recognizing the potential for a correlation versus causation error, or a classic logical fallacy. This led us straight to our flaw, straight to our assumption prediction, and straight to the correct answer. Now, of course, these are just 3 questions. There are a lot of things that can make assumption questions challenging. For example, logical fallacies we didn't cover in this video. Not except questions that force you to rule out 4 assumptions instead of locating 1. Complex argument structures with intermediate conclusions that make it hard to locate where in the argument the flaw might lie. And confusing question stems that make it hard to identify the question as an assumption in the first place. So it's worth continuing your study of assumption questions beyond this video. But regardless of the form they take, assumption questions reward a strategic approach. Breaking down the argument, identifying the flaw, predicting by negating that flaw, and attacking the answer choices using your prediction as a guide, aiming as often as possible to find the right answer rather than eliminate the wrong ones. If you like the 3 levels format of this video, give it a thumbs up to let us know we should make more like it. And if there's a specific question type that you'd like me to make a 3 levels video about, let me know in the comments. Thanks for watching, and I'll see you in the next one.